Well, hello everybody and welcome to my third attempt at recording this lecture. So, fingers crossed this time. Different computer, new presentation. So here we go. I'm now stuck in marking, so I thought I'd better do this first. So let's have a look at timber. As we said in the last tutorial, we all like a little bit of wood. People like the look of it, the texture, they like the feel of it. Freshly cut timber is nice and it's got a nice smell to it. It tends to have quite good psychological effects on people, so there's quite a lot of office buildings and that beginning to revert to more timber construction, timber cladding, timber look. So a quick introduction into timber. So an interesting pointless thing to tell you is that the word timber actually comes from an old English word, Timbrian, which means to build. And of course all original buildings were built with timber or free stone that's just lying around on the ground. So timber is basically wood that you can build with. Okay, we can engineer the stuff as well. The tree's got to be at least 600 mil in girth across, or the circumference of its trunk, otherwise it's not going to be suitable for construction purposes for various reasons we touch in later on. We're going to introduce timber and some of the products used in the construction industry, which are fairly straightforward. We're going to have a quick look at the metabolism of a tree and its constituents, which are all labelled there on the right hand side, your sapwood, etc. You may wonder why we go into such a amount of the science there. Well, we don't, we just touch on it. But once you understand the very basics of a tree, then you can understand why you get fungus attack, decay, insect attack, so you can see how that works. Then we'll have a look at a couple of ways that commercial timbers, hardwoods and softwoods, compare the two, the features and qualities. Most of that's actually in the essential readings. There's some very good resources online, which I point out as well. You'll understand how they work out the strength of a timber, how they measure it or they estimate it. There's two ways of doing it. There are highly skilled people who visually grade timber, by what it looks like, and then there's a machine that we're probably more used to nowadays. There are two forms of construction which are widely used, especially for residential and low story height, balloon platform frames, and we'll just touch on more cutting edge, trendy stuff, grid shell construction. You'll understand about the specialist use of timbers and softwood cladding, hardwood floors, joinery timbers, etc. So let's have a quick peepy-boos at these. So here's the tree. Oh look, it's a tree. Now there's immediately a piece of the tree we don't use. We don't use the twig. At least for construction we don't. But obviously it's got roots. There's the main taproot which goes deeper all the way down. And then there's a shallow root system which have got these hair zones on them. They spread out. This is where it gets most of its moisture from these areas. With a good taproot you've got on the spread here, you've got quite a stable tree in winds, etc. The trunk is the bit we tend to use. All this bit up here is obviously the crown with all the leaves on it, or the foliage, to be technical about it. I don't know the Latin name for that. The larger bits coming off are the branches, and then off the branches you get the smaller bits, the twigs. When it splits off at an angle here, that's a limb. Now the main part of the trunk that we like to use, which we can do really, is the straighter part which hasn't got many branches coming out. Because every time a branch comes out of the trunk, then it leaves a knot behind. A cross section of a tree, the tree lays down a ring every year of life. This is how you can analyse a tree by you can actually take a sample straight out of it, a core sample, and you can not only work out how old the tree is, you can actually see what the weather conditions were like, because obviously good growing conditions gives a wider ring, and bad growing conditions gives a very narrow ring, and the rings can also trap in contaminants in the atmosphere, so you can see when there's been a volcanic eruption, that sort of thing. So there's that. So the heartwood is the oldest original part of the tree, very dense. I can't even pronounce these things. The xylem is the intermediate. Then you get out here to the cambium. That's the junction between generally speaking, the deader part of the tree and the faster growing part of the tree. Here's your main bit. I'm not even going to try and say that. And then there's your bark on the outside, which is alive. So next one, a better cross section of a tree. So the very centre there, the pith. Oh wow, the pith. As I mentioned, the growth rings, 1 per year. The medulla rays, these are just little splits that occur. The cambium layer is between basically the dead bark and the live bark and the actual tree rings. This bark, dead bark, will become a tree ring eventually. So you've got live bark, dead bark, so dead here. Heartwood is most of the centre part of the tree. The sapwood is the newest rings of the tree. It's got the most moisture in. Tends to be the part of the tree that takes most of the nutrients and moisture up to the leaves. Oh, let me go back, sorry. You should note that these come from the website where it comes from, all down here, just to help you, so you can go to those if you want to. The sapwood, that's the new wood. It's just grown. It's under the cambium layer. It's a lighter colour, generally a lighter colour than the heartwood, the older wood in the middle that's matured somewhat. And as I say, it's the one that conducts the waters, the mineral salts and the food from the roots to the leaves and the top of the tree. We don't tend to use the sapwood because it decays very, very quickly. The pith, or the middle part of the tree, the very centre pith, is the centre of the tree. It's a soft, pulpy zone. It's not hard at all. It's about 1 centimetre in diameter, as it says. Can be called the medulla, and that gives its name to those medulla rays as well. But that's the original part of the tree that's grown, and it's taking nutrients up and that through the centre of the tree. The heartwood, we like the heartwood, sometimes called the true wood as well, it said. These are all dead. They're all dead cells. The original tree bit's died because it grows on the outside. That's where the strength for your tree is. Okay, all the channels and everything, all the cells and stores, they've all been blocked up now. They've all gone hard. The heartwood doesn't conduct anything anymore. The blockage is basically because the stored food convert themselves into tannins. Tannins are actually quite a good preservative as well. You get resins, and you get some other substances we're not too bothered in. But the heartwood is the bit we like to use most of all because it's much more durable than the sapwood. Just go through, shows you it again. I keep popping that in. The cambium layer is a thin layer of cells, very thin. You can't see it with the naked eye, you've got to have a microscope for it, and it's just inside the live bark. They're the cells that facilitate all the growth and thickness of the tree. They're the ones that are going to keep growing and forming the tree rings. That's an exciting slide, which I obviously forgot what it was. And you've got the dead bark, which is the outer layer. That protects the cambium layer. It also gives protection to trunks, branches, etc. Reduces water loss through evaporation. Makes the tree much more efficient. A few trees will shed their bark each year. Paper barks, that sort of thing. They'll produce it, but most don't. The live bark is the living tissue just under the dead bark. That's where all the materials, food, all that sort of stuff, they all go up and down the tree, from the roots to the tree to the branches. So that's the part that is the most alive of a tree. I strongly recommend you all go and have a look at Wood Solutions. It's a fantastic site, and I've sent out some information to you through the team's general post. Make sure everybody checks the 10 general posts. Go back a bit if you haven't seen things. There's a lot of information being provided there. So that's an introduction to a tree. You see them everywhere. We're not going to talk about koalas and things like that in trees because they eat them. Vicious, nasty little creatures. Now the strength of wood. Something to talk about it. It depends on its density. You get a denser timber, it's a stronger timber. There's two completely different ways of grading the timber. sort of estimating how strong that piece of timber is going to be. If you have a look, you can go and look up lines there. There's two methods. There's the visual strength grading, where someone with a hell of a lot of experience looks at the timber, assesses it, and then gives it a strength grading. Or there's the more modern machine grading, where a machine actually applies a force to each bit of timber, measures its deflection under a known force, and then can give it a go. There are defects you get in timbers here. You get splits and radial cracks, and you can get some insect damage. You also got to look out for knots coming out of a timber, because of a knot, a round bit. Look it up. Weakens the timber quite considerably. So let's have a look at the strength of timber. It's a brilliant material. It's got pretty good strength in compression and bending. And as I say, if you use a hard wood, a more dense wood, it will be much stronger. If you have a look at table 4.5 in the essential readings, it tells you an awful lot more about it. So the hardwood in the middle, mature wood is the strongest part. If you go to this YouTube and watch this, watch it at 1.5 times the summer suggested speed. That shows you them testing a piece of timber. I should mention timber's quite good in compression as well as bending and flexing. Now the visual grading, okay, it's the traditional way it was done, and it is still widely used for structural products. Okay, mostly seasoned and unseasoned hardwoods, as it says there. A trained grader, which just doesn't mean they're just trained, it means they've got a lot of years' experience, actually looks at and examines every single piece of timber. There are guidelines, there are grading standards they have to follow. They're looking for where the knots are and other potential strength reducing characteristics in every piece they look at. And then they apply the grading classification. Now you can see on YouTube, I haven't given you a link, there's a little interview of a visual grader. Quite interesting. He's an old bloke. I'll send around the link separately, because I didn't put it in here. Now obviously the best grade timber has got the fewest strange little individual characteristics and flaws and defects in them. Generally, stress graded structural timber is sold in Australia by the F grade rather than the structural grade number, which is more for the mechanical and machine testing. Some of the softwoods, it says there, they're thicker than 45 millimetres. They can actually be visually graded as well. If they're thinner, they can't. Most of the softwood that we bring into Australia, again, is visually graded. So, although that's the traditional old-fashioned way of doing it, it's still very, very widely used. Visual grading rules for the strength are different from those assessments for the appearance, and they vary between soft and hardwood as well. And the grading process is reliant on skill and experience, and the actual rules themselves are very complex, and they're looking for 20 different characteristics. So you can imagine it's quite a difficult thing to do. They are paid fairly well, I believe. Now, if we look at the machine stress grading use, a machine basically it just automatically bends every piece of timber, and it measures its stiffness, and it's got a general formula correlation between what the stiffness is and what the strength is going to be, and then it'll assign stress grade. There's a sorter group with a smaller range of the E, which is stiffness, that can produce a large range of strengths. They might all be the same stiffness, but they can all have different strengths. And the E value, it infers all the other structural properties: tension, compression, shear strength. It infers them. So this is part of the reason why we have when you're an engineer and you're designing timber, you tend to always have on a safety margin. So you design the timber exactly, and then you add on a percentage as a safety margin, which allows for the natural changes that are going on. Now, I have to just show you here that there's a roller that pushes down, and you can see that the direction of the board or the beam or whatever you've got goes through. it gets bent and the deflection is measured, and then they can infer or interpret from that the strength of that piece of timber. So machine grading's good. You can go and look, there's examples on YouTube of a machine doing it. Back here in Australia, most of our softwoods are graded by machine. There's a little bit in New Zealand, they do it also. So it just tells you a bit there you need to know. It's natural, remember timber's natural, so processing is the term we mean in converting the tree trunk into the usable types of timber. So conversion basically means cutting it up. So there are examples of the different sort of cuts here. So there's a quarter, you can see that's where the boards are being cut out. That one's just cut straight with a cross, that's quite good, but because you're going across the grain, that can lead to defects later on, which is why we end up having to dry the timber. You can box cut here, tangential cutting, or the back, so you can cut round and avoid using the very hard bit if you wish to. So conversion is basically cutting it up. Seasoning, new cut timber is very wet, and we need to get it. You need to get the moisture content down to 20% or less. Otherwise, your timbers are going to bend and warp as they naturally dry in the environment. So you need to get them around to the 20% or less. Now you can either do it by stacking it. This is the air method. So you stack it with gaps between all over the place. You protect it from the rain, and then you just allow it there to dry through the air. Or there's the kiln one where we force dry. It's a large oven, you stack it on a trolley, steam's pumped in, heats the timber but doesn't dry it out, because if you just dried it out in a dry atmosphere it would bend, split, warp. Once it's been heated up, then you can reduce the relative humidity, so circulate the air, and then the moisture in the wood, even though it's hot, the moisture level can actually be reduced. Natural timber, you can actually alter its properties if you heat it up. So thermally modified timber, we tend to only do this with softwood, normally pine, which is one of the most common timbers we use. You heat it up to about 240 degrees centigrade. You have to do it in an enclosed, inert environment. You can't just do it in ordinary atmosphere, because if you heat the wood to that temperature, it will burst into flames. And we don't really want to make charcoal. So if you do it in the inert environment, the timber becomes more durable, becomes more insect resistant and less moisture absorbent. So if you've got less moisture absorbent, it's not going to expand, contract, bend, warp as much. So you get a much more stable timber. But you do reduce its strength. Finland uses a lot of it, and they use something called a thermowood process. And it comes out in two classes, Thermo S and Thermo D. If you're interested, have a little look. Also, there's chemical modification, where the timber is impregnated under pressure or just coated with various chemicals to make it more resistant to insects and general decay. You can also use chemicals to reduce moisture absorption, and therefore control moisture movement, and you can include dyes that can be impregnated to give you artificial architectural colours. Lovely. So that's your strength and strength classes. Refer to the essential readings for the tables. Dimensions fairly straightforward. Obviously you can cut a piece of timber to any size and shape you want, but generally, and you go to your essential readings table 4.1, standard constructional dimensions in the codes of practices are based on timber not at 205 moisture, that should be 20% moisture content. If we have a look at the keyboard, the number 5 button is also the percent button. I obviously didn't manage to hold down the shift button enough. Hardwoods, are not controlled as much as softwoods. But you've got your standard measurements here. So, you know, you've got standard 25 by 20. I mean, in the old days, you used to use a bit in inches. I'll have a bit of 2x4 or 1x2. But nowadays, you've got it. So, this is more of a flooring plank here, number 25 there, 25 by 228. And you can see you've got different uses. You also get square section ones as well. So, but this is just the most basic ones that we use. Surface finishes, absolutely. Now, I've got to make one thing absolutely clear to everybody about any type of applied surface finish to any material. So we're talking about timber today, but this could be any other material you like. All finishes are first and foremost a protective coating. They are to protect what they're painted on. They are not initially for decorative finishing. Okay, although that's what everybody thinks they are nowadays. So a lot of effort goes into picking your colours and your decoratives and all that stuff, but it is a protective coating. So prevents weathering, keeps the wind, the rain, keeps the UV radiation from the sun out, and you need to maintain these coatings. So if you don't maintain the coatings, it breaks down. To me, that looks like a very old paint. The way it's faded, it's probably a lead-based paint, which were fantastic. But because people kept licking and chewing them, they've now been banned, apart from very special heritage uses. The two things you can go for, you can paint it on, and if you paint, that's a rough sawn cladding by the look of it, and that's going to soak straight into that. As long as it isn't too damp, soak in. And staining, the same thing. Staining penetrates deeper than paint does normally. And of course, staining lets you change colours, but they both act as a protection, a type of preservative. Varnish, normally on floors and handrails, that sort of thing. They do prevent wear a bit. They protect a bit against scuffing and light damage, and externally they are a UV barrier. Others we'll talk about next week in the tutorial. If you look here, if you go for staining, I mean that's only a small number. So you can take a bit of pine, and then you can go for cherry and pine, and that's all the colours you get by applying different stains. Their shellac stains, a traditional one. So useful, but it's protective. Initially, it's protective, not decorative. Tolerances. These are, quite good. I've got these out, a little thing down there. Normally, you're going into -1 to +3. The larger the timber, a little bit more tolerance. The tolerance is tied in with the moisture content as well. So you can't put timber too tight together in cladding or floors. You have to have little gaps in them to allow for thermal and moisture expansion and contraction. If they're too tight and they expand, they'll bow upwards or downwards because they can't move. So they'll actually bend up or down, which means the increase in length or width is taken up by a bow, or think about it carefully. So there are different types of, there's quite a wide one here. So, but it all depends where you are, what you're using it for. Moisture, as it's a natural material, it will take in moisture from the atmosphere. If it's in contact with the damp ground or damp surface, capillary action will bring it into the cells and structure of the timber. So it's important. If timber gets too dry, it will actually start to split. If it gets too damp, it'll actually begin to bend, curl and warp. It expands and contracts. Just think of it, it expands and contracts. So timber will be a slightly different size in the middle of the summer in a tropical area, like North Queensland, than it will be down south where it's drier, it's not as humid. Damp timber, 20%, is more susceptible to decay by insects and fungus. They like the dampness. Damp timber can lead to interstitial condensation. So if you build a wall, a timber frame wall, and your timber's a bit damp because you haven't stored it properly, and then you seal it all in with your claddings and that, then that moisture is going to evaporate into that enclosed space, and you will get condensation inside. It could also lead to corrosion of metal that's in contact with it, screws, brackets, etc. And it can also happen if you don't keep the protective coatings and treatments in good condition. Softwood, when it's got a high moisture content and it's quite young, it's very damp, can be really quite difficult to work with. If anyone's tried to use a handsaw to cut quite a damp piece of timber, you know what I mean. The teeth all get clogged up. Very difficult to work with very wet timber. But on the flip side of this, hardwoods, some hardwoods, generally, if you want to work with them and cut them and that, you've got to do it pretty quickly after they've been felled and processed, because they get harder and harder as they dry, and then they become really difficult to work with. Green timber, we would call it. Historically, they do that. Just look at the three main things for the deterioration of timbers. It will decay. If a tree falls in a forest and you go back a couple of years later, you'll find it's covered in fungus, it'll have insects living in it, it'll be cracked and splitting. Ultraviolet radiation from the sun is not good to basically anything. But we can delay or almost prevent these decays by using correct treatments and following construction standards and the details that are recommended. I haven't looked at details yet, so I'm leaving that for the tutorial. Fire. Most people think that's the end of timber. It's curtains for timber, fire is, but not always. If it's a large cross-section of timber, it's got good fire resistance because the outer layers char and basically turn to charcoal, and they insulate the internal part. So large structural timbers can have a very good performance to them. And then you've got the external elements, which we've talked about before already. So let's have a look. Fire. So normal size structural elements of timber, they catch fire and they fall apart and they burn quite quickly. But it's the larger, thicker ones, the larger ones, the more historic ones, shall we say, which, if it's a heavy cross-section, can actually have a very high degree of fire resistance. Okay? Timber is classified as a refractory material timber and a non-refractory timber. Refractory timber is non-resinous and does not catch fire easily. The resin burns very quickly. Examples of these timbers are sal, teak. Notice they're generally hardwoods. And the non-refractory timbers, they're very resiny and they catch fire easily. And they're sort of like, there's a few fir, and I could put a few others in there, spruce, etc. The timber surface itself, you can coat it with a solution of chemicals. It's been found that 2 coats of a solution of borax or sodium arsenate, don't lick your fingers, with a strength of about 2%, really actually does improve timber's fire resistance by a reasonable amount. And then there's the traditional way of doing it. It's Abel's process. Guess who came up with this idea? The timber surface is got to make sure it's all nice and clean. It's diluted, coated with a diluted solution of sodium silicate. See, that is still salty stuff. A cream-like paste, flaked fat lime, we talk about next week lime, is then applied to it, and finally a concentrated solution of silicate of soda is applied on the timber. That gives good fire resistance. Now, if you go to this website, Engineering Notes, it goes into a bit more detail. I mean, these came out of Engineering Notes, so I didn't change them too much. I've used them directly. That's why they're referenced, but there's a lot more I didn't include there. Termites. Nibble, nibble, nibble. More damage to Australian houses than fire, floods and storms combined. And quite often it's not included by your household insurance because it's just so common and expensive. It's normally 99.9% of the time it's concealed in locations that you don't know about, you don't look, and therefore it goes undetected for a long time, and by the time you begin to notice your door architrave or your skirting boards beginning to go a bit funny, You imagine what it's done to your structural frame. They just leave, basically, they nibble out the inside of the timber and just leave a little protective layer on the outside so it looks the same. Of course, if we're painting and everything, it can end up only the paint surface they've left. So, nasty little buggers these are. There's no real pattern for it, you can't predict it particularly. They can be in the roofs, they could be on the ground floor, they could be anywhere you like, and they travel very quickly through a structure. You can treat the timbers with boron salts. It's effective protection against attack. Been used in Australia for more than 40 years. Becoming more difficult to use some of these treatments because of the work health safety issue and dealing with chemicals. Some chemicals have been proved to be carcinogenic. But they do, boron salts, they protect sapwood quite well. And some hardwoods. So get rid of the powder post borers, which are tiny little insects that nibble. The treatment, if you're thinking, if I go to Europe, we've got some borers in Europe. If you hold up your little finger and look at your diameter of your little finger, look down there, that's how wide the tunnel is they bore. We've got good ones in Europe for that. Basically, that system so to soak in the freshly cut, unseasoned timber, so it's not been dried yet, you soak it in boron salts. You can also apply copper, chromium and arsenic salts, and there's the light organic solvent boron preservatives as well. That all came from the Forest and Wood products. If we just look, the hazard level, these are the hazards for termites, and you go from H1 to H6. Okay, very self-explanatory. Don't need to go through that one too much. When timber's exposed to the weather, its colour fades, it starts to turn a whitey grey colour, and the grain becomes a little bit more raised and open, more pronounced. This is partly why you either paint it, stain it, oil it. If you go to heritage buildings which were made with oak frames, oak turns to a silvery colour and actually becomes stronger. Any oak that was cut had to be cut to shape and worked within the first few weeks of being felled. Otherwise it started to get too high. We've got some pictures of those coming up in a minute. Timber constructions. Obviously everyone thinks of heritage, so that's a Japanese, I can't remember which one it is, Japanese castle. It's, apart from this bit for you clever buggers out there, it's all timber framed. Most of it's done without any mechanical fixings. It's all built with pegs and interlocking joints. It's good stuff. But don't think we've finished, because a couple of years ago, 75 King Street in Brisbane, a high-storey office building was constructed. It is timber framed. Admittedly, these are laminated timbers that are being used, but it's all timber and it meets the fire regulations. Lovely open plan. Over here you can see there's a bit of wind bracing built in over here. Timber ceilings and floors above. Look at the size of these lovely laminated beams. It's a beautiful piece of work, lovely building. So we said we were going to look at platform frames. It's one of the most common that we use. It's used for houses. Basically, the first floor joists are covered over with a subflooring, basically sheets which are fixed to. It actually creates what's known as a diaphragm floor, diaphragm surface, and then you've got a surface that you can then start building the first floor from. The external walls, internal partitions are erected directly off those. So that this is timber flooring down here. So you lay your foundation, put your joist down, bang, floor surface, and then on top of the floor surface, you then build your partitions and your walls. Okay? You can build most of the framing on the floor and then lift it up into place. That's quite a common way of constructing it. There's a picture, just a bit of it. You see, those internal partitions and that external wall over here are built straight off the first floor. So there we go. This was my house being built 10 years ago. That's now actually got a what do you call it, a bubbly bath thing in it my wife insisted on, but she never uses. Ha ha. Grid shell. Grid shell. It's been around for a long time, grid shell is. It basically gets its strength from its double curvature in a three-dimensional space. And you can see this is a lovely one here. Let's have a little look. You've got this lovely, this thing is beautifully done. It's interesting, exceedingly strong. But as you can imagine, the calculations to design it are quite complicated. So smaller ones used to be designed many years ago now. But with the advent of increasing computer power, which has allowed the designs and the computer analysis to become more complex and more granular onto smaller levels, we can now design immense grids. Okay, they've become increasingly popular because of the computerisation it's allowed us to do it. They're very economical in comparison to the amount of material used to build them, but the size of the floor area they can cover. So they're very economical that way. A little bit of historical stuff. That's a timber ceiling from a 14th century chapel in a cathedral. Can't remember which one. But as you can see, it's beautifully done, lovely jointed. It's all traditional timber jointing. There's no screws or nails used in that. It's all pegged. Look at some photos. So there's a traditional timber frame property, obviously from England. These curved bits were from timbers that were curved in the first place. This is all oak. Notice I said it goes a silvery colour. You can see the framing on the side here. Interestingly, the brickwork is a later infill. This would have been known as a wattle and daub, which we could look at later on for you if you wish to. And you can see this is an infill brick, but these are plastered, lime plaster, over a lattice of timber and reed, which is the wattle and daub. That's an original window which would never have had glass in it in the first place. LED lights. It's all timber. You can see where it's awful. So it was traditional that you'd jetty, so you'd stick out past the bottom wall a little bit, and they're the floor joists of this room here, and that has a structural advantage because if you jetty out, it stops your floor bending so much. But at some point in time, they chopped them off here. Interesting, isn't it? But that's all timber. This doesn't need anything. You often see they're painted black. That's got nothing to do with it. This was painted black, but they were beginning to allow it to weather again. Oak doesn't necessarily need a protective coating on it. There's another example. Zoom you in there, and you can see the same things. This very close together gives you an indication that it's quite old. There, which I don't think, no, I can't. That's an exposed bit of the wattle and daub there. You can go and Google wattle and daub. This is an oriel window, but I go off subject there, which we don't want to know. That's a nice one. This is an old grain store, and you can see it's all timber. They're stone slates, Collie Western slates, I would think, from an area called that Collie Western, north of London. But notice these beautiful arcs, absolutely lovely. There's a lot of timber in that, but it's absolutely beautiful. And something a little bit more, just showing you a bit of timber cladding, which they're not actually looking after this terribly well here. This is in Ipswich, in Queensland. It's all peeling off. It's getting the sun now. If that keeps going on, this will start to decay. The building itself is edging on to 100 years old, so it's doing quite well. And just show you a much more modern example. This is the London Olympic Village. This was the aquatic centre, the swimming pool, I believe. And this is all timber clad. Beautifully clad. Look at this It's just lovely. Just lovely. I've lost a bit of the colour on that when I put it in here, but it's a beautiful, beautiful building, this is. But high maintenance that needs, because that's not oak. That needs coating all the time. And when we're looking at cladding, these are the different patterns you can have of cladding here. So they're all the flat ones. Generally, if you just get them, so there's a little nib. That helps, doesn't it? This is a water break, so when the water runs down the outside, it doesn't soak in, it drips over these bits. See, you've got a water break there, another one there, another one there, a little nip there. That one doesn't work as well. And then you can end up with shiplap. They work really well, and that's not too good at all. I wouldn't bother using that because that could bring water in. I know it's sloping to the outside, but it still could allow some water to penetrate there. How do I get back out? Come on. There we go. Balloon frame. Okay, you see that we've got concrete footing around the edge here. Okay. The exterior walls, the internal studs, the first floor joists, they're all anchored on a sill, a concrete sill in this case, although it says freestone there, but concrete, so you've got an all-in foundation, put a sole plate on it, bolt it down, bang, and you build straight off of it. And it goes all the way up. The external walls tend to go all the way up to the second floor. That's called a balloon one, and it's still quite commonly used as well. I don't get into too much detail because when you do materials too, you do a lot more on this. Trussed construction is what you tend to see on most new buildings nowadays. It tends to be the truss refers to the roof and sometimes beams and floor trusses. Trusses can span a pretty wide area for a low use of material and a low weight. So a king post and a queen post are the more traditional heritage type. Raised tie. This one allows you to have an attic room. That one lets you have a flat roof on the top for some reason if you need it. Obviously monopitch roofs. So they're really good. And of course they're designed and manufactured in a factory. Your quality control is really very good on those, as it is with the platform frame materials, which can be made in a factory. Timber products, I'm just going to run down them. You can get frames for your platforms, etc. You can get floorboards, you can get window frames and windows themselves. You can get doors, door frames. You can get plywood, which is used for flooring. It can be fitted to the outside of a timber frame to give it shear resistance so it doesn't fall over in wind. You can get laminated timbers, and I showed you that picture of the one in King Street in Brisbane where they've been engineeringly glued together to make larger, higher strength elements that we can use. Medium density fibreboard is just, well, it's really sawdust stuck together, for want of a better terminology. Chipboard, chippings are then moulded and glued together to create floorboards at sometimes. You've got architraves and mouldings and cornices and skirting boards and all that sort of stuff. Fences, external cladding, internal feature cladding. Timber can be structural or decorative, and it goes on. It goes on. So we can talk about some that aren't included in that when we get to the next week's tutorial. And that is timber products. I hope you've enjoyed timber products. Lovely. Go out and strike a piece of timber. This is one of our favourites. I'm then going to carry on with marking before I finish off lime, cement and concrete for next week. So I hope you're all having a good week. See you then. Now I'm going to work out how to turn it off. Oh, I'm so good at this stuff. Where is it? There's me echo. And where do I stop it? What's going on? You know, I can't stop it.